Hello. My name is Darren and I will be helping you understand the ozone layer today. But first, here is a poem to help you remember the layers of the ozone.
Once upon a time, before the Romans warmed their feet and dinosaurs walked the street. About 530 million years ago, in fact. The ozone layer was still intact. Up in the sky. Oh, so high. The first layer is the troposphere. And we breathe it all the way down here. Oxygen 21, nitrogen 78. Isn't it just great? Little argon and carbon dioxide. Allowed animals to climb onto the seaside. Up next is the stratosphere. Here meteorological balloons now appear. Here lies the ozone. Anybody up here would be very alone. UV rays are absorbed. Just above the Concorde. 50,000 meters up. There's something you can't make up. High in the mesosphere. Santa rides his reindeer. Wizards on broomsticks fly into the thermosphere. Although the law in Swaziland says they have to stay near. Lastly, the thermosphere. Just outside you can grab a souvenir. A space rock. But be careful, it's very hot. That concludes the poem tonight. But don't leave yet, for there's more dynamite.
Now let's get on to the real science. You may be wondering why ozone is so important. Well, it is because ozone acts as a barrier and protects us from high-energy ultraviolet radiation. This UV radiation is produced from the sun and it is extremely dangerous to us. This radiation is what causes skin cancer. Before we properly start, we need to know what bond fission is. Bond fission is the breaking of bonds involving the redistribution of electrons. There are two types, homolytic and heterolytic. In homolytic fission, two electrons go to each atom, meaning that the atoms have no overall charge. This is common in nonpolar molecules. Heterolytic fission is when both shared electrons go to one atom, making it negatively charged. This is common in polar molecules. We also need to know what a radical is. A radical is a molecule or atom that has unpaired electrons. This makes them highly reactive. To work out the energy of a photon, you need to use the equation E equals hf. E is the energy of the photon, f is the frequency of the radiation, and h is Planck's constant, 6.63 10 to the minus 34 joules a second. Finally, we need to know what initiation, propagation, and termination mean. Initiation is a chemical reaction that leads on to a secondary reaction, for example UV light splitting O2 molecules. Propagation is when a chain reaction occurs and a highly reactive molecule is continuously remade. This is why the ozone cycle exists. O3 is repeatedly made. Lastly, termination. This is a chemical reaction which inhibits the remaking of a highly reactive molecule. This is what happens when CFCs interrupted the ozone cycle. So how is it made? Oxygen rises to the stratosphere where it is hit by this high UV radiation. This breaks the bond between the O2 molecules. The electrons become excited to a higher energy level so that the molecules can no longer bond together. This is called photodissociation. During this process, the bond between the O2 is split equally and you are left with two oxygen radicals. This is the initiation step within the reaction. From this point, three reactions can occur. OO equals O2, OO3 equals 2O2, and O plus O2 equals O3. O3 is ozone. If O3 is made, then the propagation step begins and it is continuously remade through these three reactions. This can also occur in the troposphere when UV rays hit photochemical smog. The radiation hits nitrogen dioxide, turning it into oxygen, which then reacts again to form ozone. It can be dangerous for us to breathe this in. The production of ozone is homolytic. There was finally something we thought we could easily sustain, but then some bloke decided to ruin it all. Thomas Midgley invented CFCs in 1928. At first, the entire world thought they were a brilliant idea. It stands for chlorofluorocarbons and it contains what you'd expect: chlorine, fluorine, and carbon. They were used as refrigerants, aerosols, and solvents. They had great properties such as being insoluble in water, having a low boiling point, and being unreactive. But something always has to go wrong. Data came out suggesting that the CFCs were damaging the ozone layer and depleting it. This was later found to be true. So how do they do it? Well, when CFCs were released into the stratosphere, they began reacting with the high-energy ultraviolet radiation. This released chlorine into the stratosphere, which then reacted with the radiation to form chlorine radicals. These radicals then reacted with ozone, producing Clo and O2. After this, an oxygen radical would then react with Clo, creating a Cl radical and O2. This was a problem as the overall reaction meant that two O2s were produced, but the chlorine radical was still left at the end, meaning that it could go on to react with more ozone. This is an example of homogeneous catalysis, a chemical reactions in which both reactants are in the same state. It has been said that a single CFC molecule can destroy 100,000 ozone molecules. This quickly led to the depletion of the ozone and a huge hole in the ozone layer. At one point it was 21.1 million square kilometers wide, which would have had a large impact on the communities found where the hole was. Luckily, at its largest, the hole was over the Antarctic, so few people were affected. Thankfully, in 1989 the Montreal Protocol was placed, which was a ban on the use of CFCs and other ozone-depleting chemicals, which allowed the ozone layer to stabilize in the mid-1990s. The ozone layer is estimated to reach pre-1980 levels in 2075. There was one chemist, at least, who massively helped and altered the world as we know it. Eugene Schuler invented sun cream. Sun cream is designed to protect us from the high-energy ultraviolet radiation that can cause us health problems. Sun cream absorbs the radiation, which breaks the bonds between the molecules. This is why you have to reapply every 2 hours. If there are no bonds, it can't absorb the energy and therefore you will die. Thank you for watching.